Okay, for the second part of this lesson, I'm going to show you how to take an equation, turn it into one of the general ellipse equations above, and then how to translate that into the graph. So for the first problem, what we're going to do is we're going to take the x's and we're going to complete the square, and we're going to take the y's and complete the square. So in order to complete the square with the x's, I'll need to pull out a 9. That'll leave me with x squared plus 4x. And then I'll fill in the value to complete the square. I'll take half of 4 and square it, which is 4. And then for the y's, there's no value to take out front, so I'll just go straight into completing the square. I'll take half of 2 and square it, which is 1. And then on the other side of the equal sign, remember that I need to add both of those values in. So I technically added 36 and positive 1. Okay, next step is to factor. I remember that I set this up so that these factor nicely into x plus 2 squared, y plus 1 squared, and then everything on the right side is going to reduce to positive 36. All right, now in order to get the fractions like you see in the ellipse equations above, what you want to do is you want to set it equal to 1. Notice both of these have it equal to 1. And so you're just going to divide by the number that's over here on the right side. So if I divide by 36 all the way through, now I have a value of 1 over here on the right side. And then for my x's, 9 over 36 reduces to 1/4. And of course, the y's, I don't have a number in the numerator, so I just have a 36 in the denominator. All right, so this is the equation of the ellipse that we're going to graph. Now, remember we said that the number that's underneath the x's, you go that many in the x direction, and the number that's underneath the y's, you go that many in the y direction. Of course, when I say go that many, that is always from the vertex. So the vertex of this graph is going to be at -2, -1. I'm going to go 2 in the x direction. We'll call that b is 2. So 2 in each x direction. And I'm going to go 6 in each y direction. I'm taking the square root of the numbers that are in the denominators. And the a and the b values don't really matter so much which one's a and which one's b, but a is always the bigger one. 1, 2, 3, 4, 5, 6. Okay, and then there is my little ellipse. What I'll often ask you for, what are the coordinates of the vertices and co-vertices? So just keep in mind that this is a vertex, this is a co-vertex. The vertices are always larger and the co-vertices are always smaller. So if I ask you for the coordinates, of course, you would just list out those actual points. And then finally, what I need to do is find the foci. So remember, in order to find the foci, we're going to use c squared equals a squared minus b squared. Okay, so a is always this larger distance. We said that that was 6. And b is the smaller distance. We said that that was 2. And so when I go through and do this math, I'm going to get 36 minus 4, which is 32. So c is the square root of 32. Now the part that always gets people is where that value falls. That's not a pretty number, but that value falls on the major axis. So the square root of 32 is approximately, 5.66. So I'm going to go about that many on the major axis. So it's going to be really close to the vertex on both ends. Okay, that's where I put the c values. Now, in order to write the coordinates of the foci, you're not going to have an actual value there. So think about what the vertex was. The vertex was 2, -1, and you've just added a value to that y value. All 3 of those points, my center, and my foci are on the line x equals -2. So the foci are going to have coordinates of -2, and then the -1 value, I added and subtracted the square root of 32. Okay, and in this case, I added them to the y value because I was on this major axis that is vertical. All right, another problem. Okay, next example. I'm going to take out a 9. And I'm going to take out a 16. Now notice I kind of rearranged this equation in my mind so that the x's were together and the y's were together. So that might be a step that you want to completely write down instead of doing it in your head. Okay, take out a 16 from 64, and that'll leave me with 4. I'll add on a 4. I'm going to move this 44 to the other side, and then I'm going to remember, what did I actually add on to both sides? I added 36 and 64. Okay, then I factor, and all of this reduces to 144. I'm now going to divide everything by 144. And that leaves me with x minus 2 squared over 9 over 144 reduces to 1/16. Y plus 2 squared, 144 divided by 16 is 1/9 equals 1. Okay, so when I get ready to graph this, the vertex is going to be at 2, -2. I'm going to go 4 in the x direction. I'm going to go 3 in the y direction. And here is my ellipse. In order to find the foci, I'm going to remember to use this equation here. Remember that A is the larger distance, and so A in this case was 4, and B is the smaller distance, which is 3. So 16 minus 9 is going to give me 5. And so the square root of 5 is how much I'll go on the major axis to get my foci. The square root of 5 is approximately 2.23. So I'm going to go about that much in each direction. And then if I wanted to write the equation, or I'm sorry, the coordinates for the foci, the vertices and the co-vertices, you can just grab them from the actual values on the grid. But the foci in this case, remember the vertex was at 2, -2, and I've added in the x direction. So this time I'm going to take 2, and I'm going to add or subtract √5 from it to get the foci coordinates. And then, of course, all 3 of those points are -2 units down. And so those are the coordinates of the foci.